This is a continuing lecture on the fundamental integration formulas. We have the following formulas for integrals that involve exponential functions. The integral of a raised to u du is a raised to u all over ln of a plus c. A is a constant and u is a function. And before we can apply the formula, we have to check the differential of the function u. Once we have done that, the integral is equal to a to the u with a constant 1 over ln of a plus c. The next formula is even simpler. The integral of e raised to u du is e to the u plus c. So after checking on du, e to the u du is equal to e to the u. So here is a function wherein the integral is equal to the function itself, provided that e to the u comes with its differential du. We take on the following examples. So we start with the integral of 4 raised to t dt. Our a in here is equal to 4. Our u is t, and its differential du is dt. So the answer is quite outright. The answer here is a to the u, or 4 raised to t, divided by ln of the constant 4 plus the constant c. Next, the integral of the quantity 2 plus 3 raised to x quantity squared dx. So what we will do here is we will expand, and in expanding we will be getting 2 squared, or 4, plus twice the product of 2 and 3 raised to x, so that will be 4 times 3 raised to x plus 3 raised to x squared is equal to 3 raised to 2x quantity dx. Then we integrate term by term. The integral of 4 dx is 4x plus, we have the coefficient 4. The integral of 3 raised to x dx is of the form a raised to u. Your u is x, and its differential is dx. So that will be equal to a to the u, or 3 raised to x, all over ln of 3, plus the integral of 3 raised to 2x dx. Again, a is 3, your u is 2x, whose differential is 2 dx. So we need to complete our du, so we have to introduce 2, and as a consequence there will be 1/2 in our answer, and a to the u du gives us a to the u all over ln of a. In this case it is 3, plus the constant c. So that is now equal to 4x plus 4 times 3 raised to x over ln of 3 plus 3 raised to 2x all over 2 ln 3. Now 2 ln 3 can be written as ln 3 squared. No? 2 becomes the exponent of 3, and we know that 3 squared is 9, so we have ln of 9 plus c. Okay, then we have the next one, the integral of 4 raised to x times the quantity 3 raised to x minus 2 raised to 2x dx. So, okay, So what we do is we distribute 4 raised to x. So we'll be getting 4 raised to x, 3 raised to x, minus 4 raised to x times 2 raised to 2x quantity dx. Now 4 raised to x times 3 raised to x can be written as 4 times 3 raised to x. And then the other one is 4 times 2 squared raised to x quantity dx. Alright, which is equivalent to the integral of 12 raised to x minus this one is 4 times 2 squared. We know that 2 squared is equal to 4 multiplied by 4. That will be 16 raised to x quantity dx. So each of these is of the form a to the u. Alright, your u is x and du is dx. So the integral of 12 raised to x is 12 raised to x all over ln of 12 minus the integral of 16 raised to x dx is 16 raised to x all over ln of 16 plus the constant c. So let us continue with the next one. We have the integral of the quantity e raised to 3z plus e raised to negative 3c squared. So here's a case wherein we have to expand our integrand. Expanding, that will be equal to e raised to 3z squared or e raised to 6z. Then the middle term will be twice the product. So that will be 2 times e to the 3c times e to the minus 3c. So we add the exponents 3z and negative 3z, which is 0. So it will be e raised to 0 or 1. So it's simply equal to 2. And then e raised to negative 3c squared gives us e to the negative 6z dz. So we integrate term by term. E raised to 6z. Our u here is 6c and du is 6dz. So it lacks c to complete the differential. So what we have is e raised to 6c times 1 over 6. Then 2dz is 2z, and e raised to negative 6c, your u is negative 6c and its differential is negative 6dz. So that will be negative 1 over 6 e to the negative 6z plus c. Next, the integral of the square root of e raised to 3x plus 4 dx. Being a radical, we can rewrite our integrand as a power with a rational exponent, e to the 3x plus 4 raised to 1/2 dx. And using the rule for powers, the power of a power, that will be equivalent to e raised to 3x plus 4 all over 2 dx, or e raised to 3/2 x plus 4 over 2 or 2. So obviously our u here is 3/2 x plus 2. Of course there is a dx here, right? So if that is your u, your du is 3/2 dx. So it lacks 3 halves to complete our du. Our answer will be the reciprocal, 2/3 e to the 3 halves x plus 2 plus c. Or you may rewrite this as a radical, the square root of e raised to 3x plus 4 plus c. And then number 6, this is equivalent to the integral of e raised to square root of x plus 4 square root all over square root of x plus 4 dx. Alright, so this will be equivalent to e to the u. This part here is e to the u, and then there is a square root. So we can write this as e raised to square root of x plus 4 over 2 all over square root of x plus 4 dx. Okay, there. So what is our u here? Our u is the square root of x plus 4 all over 2. Okay, let us write that. U is equal to the square root of x plus 4 over 2. So your du here will be 1/2 x plus 4 to the negative 1/2. Derivative of x plus 4 is 1, and then there is still 1/2 dx. So that will be 1/4 1 over the square root of x plus 4 dx. So we already have dx over the square root of x plus 4. It only lacks 1/4 not to complete our du. So our answer here will be 4. And then e to the u du is e to the u, or e raised to square root of x plus 4 all over 2 plus c, which is of course equivalent to 4 square root of e to the square root of x plus 4 plus c. So we take on some more examples. The integral of e raised to x plus 2 quantity squared over e to the minus 2x. Well, we expand the numerator to x, or to e raised to 2x plus twice the product. That will be 2 times e to the x times 2, or 4e to the x plus 2 squared. That will be 4 divided by e to the negative 2x dx. So each of these is divided by e to the minus 2x. So that will be equivalent to that will be equivalent to e raised to 2x divided by e to the negative 2x, or e raised to 4x. E to the minus 2x goes up. It becomes e to the positive 2x multiplied by e to the 2x. That will be e raised to 4x plus 4 e raised to x over e raised to minus 2x. Again, e to the minus 2x becomes e to the positive 2x times e to the x. That will be e to the 3x plus 4 over e to the minus 2x, equivalent to e to the positive 2x dx. So we evaluate e to the 4x. Your u is 4x, differential is 4 dx. So what we'll figure out in the answer is 1/4 e to the 4x plus 4 e to the 3x is 1/3 e to the 3x. And 4e to the 2x will be 4 over 2e to the 2x plus c. Of course, we can cancel this, and that is equal to 2. All right, so we have number 8. 4 raised to x, e raised to 2x. Now, we can write this as 4 e squared quantity raised to x dx. No? So one of the rules about exponents. So 4 raised to x times e squared or e raised to 2x is the same as 4e squared quantity raised to x. So your a here is 4e squared and your x is u, the differential is dx. So the integral of a to the u is a to the u, 4e squared raised to x all over ln of 4e squared. So ln of a, your ln of a is 4e squared plus the constant c. Or you may write this as 4 raised to x e raised to 2x over ln of 4 e squared plus c. You may now try working on the following exercises. Thank you for listening.